Okay, let's give you guys some more practice. So here, try to find out the limit of this function here. Okay, and if you try and do it this way, this is if you try and break into this and this here. So if you try and do it this way here, our normal routine is to break into this bubble and break into this bubble, and once we've broken it up, we can actually break into this bubble and then into this bubble here, and then hang on, bear with me. Yeah, if you try and do it this way here, you would get 1 take away 1, and then this whole thing here would be 0. So you would get 0 over 0, which is well, you can't really deduce much from it. So the minute you see something like this, you need a new approach. Okay. Well, if you try and basically break into this bubble here, break into this bubble like this here, you it won't work. There's something else that you have to do. There's something that's cunning that you have to do before you can do this. Okay. Well, here, try to factorize this, and then it will lead you. It's just a trick. If you factorize, then well, anyway, have a go. Press pause and have a go. Okay, so the limit of this here would be this. Try to factorize this. It's just a trick. You see, when you factorize the bottom part, it will give you 2 bubbles here, like this, and these 2, they will cancel out. Well, it's just a trick. So here, these 2 will cancel out. So if here you divide top and bottom by the same bubble here. So this bubble divided by this bubble will give you 1. This whole thing here divided by this bubble here, it will give you this. Okay, so basically these 2 will cancel out. Remember, yeah, it's got to be 1 on top, because you're dividing by, well, this exact thing divided by this exact thing, it will give you a 1. Well, anyway, once you're in this form here, then you can see that you can put pretty much, well, okay, so you can say this. You can say equals the limit of 1 over the limit of x, and then plus the limit of 2 as x approaches 1. Well, this thing here will be 1. This thing here, as x approaches 1, it would be 1. So it'd be 1 plus 2. So the whole thing here would be 1 over 3. Okay, and if you hang on, if you try and plot this graph, hang on, let me see. Try and plot the graph here. If you plot the so here, hang on. If you draw the graph of so this was our original function here. So if you plot this graph, it will give you this line here and this line here. We were trying to find out the limit as x approaches what was it? X approaches 1 here. We were trying to find out the limit as x approaches 1. So what that means on this graph is that, hang on, what that means is on this graph here, as x approaches 1, so 1 is here, so as x approaches 1, from the left hand side it will be this, and then from the right hand side it will be this here. So we worked out the limits here will be 1 over 3 as x approaches 1. Okay, well, looking at this function here, you can see there's something weird happens at minus 2. So if you try and find out the limit as x approaches minus 2 here, you should not. Well, if you try and find out the limit of this as x approaches negative 2, well, from the left hand side you will approach negative infinity. From the right hand side you will approach positive infinity. Well, let's try and do it anyway. So here, so this was our original function here. We are trying to, so these 2 are the same. We are trying to find out the limit as x approaches negative 2. So that's this here. Okay, we are trying to find out the limit of this function as x approaches 2. So look what happens. Okay, if you so here we are trying to find out the limit as x approaches negative 2. Again, use the same technique. Factorize this thing, so these 2 will cancel out, giving you this here. Okay, and then when you get to this stage here, you can break into this thing here and break into this thing here, so it becomes this. Okay, so this thing here at the top, at the bottom here, it will be the limit of this, and then the limit of this. Okay, and then remember we're trying to find the limit as x approaches -2. Well, as x approaches -2, this will be 1. This one here will be -2, and this here, well, it will be 2 here. So you will then get to this. Okay, now here you've got to use a theory which I haven't a theorem which I haven't shown you yet. You see, the limit at the top approaches that the limit at the top here, the limit exists other than 1. So the limit exists and it's not a 0. And then if you look at the bottom here, the limit of this is 0. So whenever you have a limit at the top other than 0, a number other than 0, and the bottom happens to be 0, then you can conclude that the limit does not exist. Okay, it's just a theory which I haven't shown you yet, so I will in due course. But for the time being, whenever you get a limit other than 0, and then at the bottom it's 0, then you can say that the limit does not exist, which is true when you look at our graph. You see, we were trying to evaluate the limit as x approaches -2, and you can see here the limit does not exist. Whereas earlier we tried to evaluate the limit at x approaches 1. The limit here does exist, whereas here it doesn't exist. Okay.